Hi, Assalamualaikum. My name is Nurfaizatulaina Binti Ahmad, S50832 from Group 2. So, I'm going to present Task 1. Objective of research is to characterize the surface morphology and to identify the molecular structure of the product. Let's provide instruments, theoretical basis, and industries. The first instrument is single crystal X-ray diffraction. It is used to determine three-dimensional of crystal, provides accurate and precise measurements of molecular dimension, and used for identification of natural product or of the product synthetic chemistry experiment. Second instrument is scanning electron microscope or SEM. It can scan a focused electron beam over a surface to create an image and producing various signals that can be used to obtain information about the surface topography and composition. So, let's proceed to theoretical basis of single crystal X-ray diffraction. X-ray diffraction is based on constructive interference of monochromatic X-rays at a crystalline sample. It is generated by a cathode ray tube filtered to produce monochromatic radiation, collimated to concentrate, and directed toward the sample. The figure shows is a schematic of single crystal X-ray diffraction principle. Next, the interaction of the incident rays with the sample will produce constructive interference and a diffracted ray when conditions satisfy Bragg's law. The figures shows that this law relates the wavelength of electromagnetic radiation to the diffraction angle and the lattice spacing in a crystalline sample. So, diffracted X-rays are then detected, processed, and counted. So now, let's proceed to theoretical basis of scanning electron microscopy. The scanning electron microscope produces image by scanning the sample with a high energy beam of electrons. As the electrons interact with the sample, they produce secondary electrons, backscattered electrons, and characteristic X-rays. These signals are collected by one or more detectors to form image, which are then displayed on the computer screen. The figure shows is schematic of scanning electron microscope's principle. Then, when the electron beam hits the surface of the sample, it penetrates the sample to a depth of a few microns, depending on the accelerating voltage and the density of the sample. The figure shows how the electron beam hits the surface of the sample. Many signals like secondary electrons and X-ray are produced as a result of this interaction inside the sample. The maximum resolution will obtain in an SEM depends on multiple factors like the electron spot size and interaction volume of the electron beam with the sample. So next, let's proceed to the industries that use single crystal X-ray diffraction. It is microelectronics industry. Microelectronics industry use silicon and gallium arsenide single crystal substrate in integrated circuit production. There is a need to fully characterize these materials using the XRD. XRD topography can easily detect and image the presence of defects within a crystal, making it a powerful non-destructive evaluation tool for characterizing industrially important single crystal specimens. SEMs offer the ability to examine a wide range of materials at high and low magnification without sacrificing depth of focus. So, SEM are most used in forensic investigation. It is for handwriting and print analysis, theory examination, analysis of gunshot residue, and examination of banknote authenticity. Thank you for watching my video presentation. I hope that all the information that I had given for task 1 are good. So I hope that you can consider to give me the highest mark for these stars. Thank you.